Uh, Good afternoon, everyone. Welcome back to the EvilTreeHouse for my third video on pixi.js. As promised in the last video, today we were going to talk about creating a control scheme. So that would be using your keyboard and your mouse to actually create things that are interactive. When I sat down and actually write this episode, I started to think that now might be the time to diverge into or diverge away from just doing pure prototyping and look at something a bit more substantial in terms of how we're going to go about creating solutions going forward. Usually with prototyping, because we're talking about games, we're talking about entertainment, it's really all about getting it functional as fast as possible. Because the faster you can get to the fun, the more you can figure out what needs to change, what works, what doesn't work. And you can worry about refactoring and polish and all that stuff later on. If you spend a lot of time thinking about how are you going to build it out before you even really know what it is, you tend to find yourself in a quandary where you're stuck or you've lost your motivation and you tend to abandon things. I know, I've done it a lot. So I kind of changed the way I was thinking a while back when it comes to games, and just to get stuff out as fast as possible so that I can see it work. And you'd be surprised how big of an impact that has on how well you develop going forward. So the first two videos was pretty much the get it functional principle. Code was written pretty quickly. I would say it was at least legible. It was simple to understand and intuitive. It just wasn't really written in a way that could make it reusable. So I think starting with this video, we're going to start really looking at how one can actually create and maintain their own game engine. So in that respect, the engine will sit on top of Pixi. Pixi will act as the visual framework that manages getting pixels to the screen. And then you'll have an engine on top which handles things like all the setup, initialization, management of all your game assets and resources, entities, etc., which power your mechanics and your dynamics. Those are the two primary foundational pillars to creating a gaming experience. So with this video, we're going to kind of look at how to kind of outline and carve out the concept behind a very simple basic game engine that hopefully we'll build onto as the video sets go forward. So as promised, today we're going to build a control scheme, but first let's take a look at what we have. We have this lowly undead 32 by 32 sprite here, standing in the middle of a gray background, doing practically nothing. I can press the arrow keys all I want. I can click around. There's no interactivity at all. It actually is running. It is rendering at 60 frames a second. There's just nothing going on. So today's primary task would be to change that. So looking back at our code here, you'll see that the index HTML page has gotten a lot simpler because I've kind of already outlined the basis of a game engine here. You'll notice that in addition to main, I now have a game.js library that I load first. And then when my page is loaded and I call setup, I actually do something a bit different. For those of you who've used XNA in the past, this might look very familiar. I kind of borrowed how it did its engine initialization process. You essentially create a subclass of their game class, and that's what holds all your game logic and dynamics, mechanics, aesthetics together. So the setup here creates a new demo game, which is what I called this video 3 project. I pass it nothing more than its resolution and the background color to the canvas, and I call run, and that's it. That's all I have to call on this front page. So most of that stuff is inherited from the main game module, so I don't have to really write a whole lot. So let's take a step back. Let's go look at the main.js where I define demo game. So all demo game does is it calls in its constructor, it calls the game constructor, passing the arguments that it received, the width and the height and the background color. And then it calls this special method called extend_to, which just handles making sure that the prototype of game gets extended into demo game. From there, I set up a few basic, I hate to use the term global, but for this case, global variables that define the zombie element or the sprite so we can keep track of it. How fast we want it to move when it does move via keyboard input, and a placeholder for figuring out how fast it moves per frame. So that'll all be written up here in the near future. The game engine, when run is called, will call the init function. This is kind of like what I like to think of as the prelude to this building the scene. We'll definitely get into more things like game states and all that fun stuff later, but for now let's just pretend this game or this interactive experience has one state, and init is how you build it out. The first thing you do is call, again, games init method to set up all the global stuff that needs to happen there. From there, I can calculate my frame speed, which is nothing more than how fast you want it to move per second divided by how many frames we can render per second. Pretty simple math there. Here is where we'll ultimately set up our handler to manage moving, or to manage capturing the input properly so we can move our zombie around. This stuff should look pretty familiar from the previous video. We're going to load the zombie PNG file, which is a single cell, set up the sprite, place it in the center of the screen, and add it to our root scene. This root function is a method of the game class that gives you the root container. So it's the most parent container in your game. And return true, which just basically means everything worked, so you can launch the game loop. Every time the game loop runs a single frame, it calls the update function. This is, again, very similar to how XNA works. First thing you do is you call games update function. If it ever returns false, you should also return false. This is how you can basically cut the game loop off, stop it in the middle of running for either an error condition or because you programmatically want it to stop. Once we've done that, assuming we're continuing, we would end up moving the zombie during this part based on the keyboard input that we're aware of, and return true so that we continue going forward. And last but not least, I set demo game up to the global namespace so that index.html can actually see it here. So that's what we had to build on top of my game module. My game module here, I probably need to put this up on my GitHub or some place where people can actually get to this code, because it's obviously a lot to go through in a single YouTube video, but I'll just kind of breeze through it here and point out the places we're going to need to update it, because currently this game engine really only handles building the scene, setting up the render loop, and running. That's all it does right now, so it doesn't really do anything relating to input, which is our purpose of our video today. But a lot of this code was borrowed from the previous video. It was just kind of refactored in. We keep our configuration that comes in locally. We set up a few important game globals, our renderer, our root container, and this is our interval for our run loop to make sure it executes properly at the right rate. I guess if we just go down here to our init function that we mentioned earlier, you see we build our render, which just figures out what kind of render to create, how big to create the canvas based on the configuration we passed in, set the background color, and build our root container. That's it. Ultimately, we're going to add our manager init stuff here, if there is any, and then return true. Our update, currently all it does is say everything's okay, because it doesn't have anything that it does personally. We'll update that to support our keyboard input manager. And when we call run after everything's set up, we run the init process, which I just described, and if everything is okay, this is where it sets up the run loop. So this is a function that's going to run approximately 60 times per second as defined by the FPS value. and this is when it's going to handle running the updates on all the proper classes and then exiting if it gets a false condition. So this way all this stuff is hidden back here in this library. We never really have to consider it in the future, which is really the whole point of abstracting this engine down into separate classes, is that we can really focus on the portability of these classes. We can copy them into a new project and then only focus on the ones that we need to change for our specific needs. So this video is kind of not really directed at creating a game project as much as it is showing the idea behind a game engine and extending its functionality. So I guess no real reason why we don't just start extending it right now. So we know what we had. We had a video essentially of a zombie standing still. Not very exciting. So we're going to get underway in making that a bit more interesting. So first, in our game directory here, we're going to create a new class called Keyboard Manager. So this is the one that will host all of our keyboard pertaining things. Those of you who've done JavaScript development before, a lot of this is going to look pretty cut and dry. The way I do it is, again, akin to how XNA does their keyboard tracking, which is instead of actually triggering code to fire when you actually press the keys. I guess this is also similar to how GameMaker works. I've never used it, but I hear it's how it works. Instead, our keyboard manager is just going to, when keys are pressed or released, it's just going to keep track of the state. And then in the update function for your game, you get to interrogate that state in basically in all one big monolithic function, and then make your changes accordingly. So that way you're not having code fire at strange rates, and sometimes it might fire out of order, or you want to press two keys at once, but because one was fired before the other, it didn't realize both were pressed. It's just an easier way to do it. We'll just initialize this by doing a simple constructor. I want to get the reference to the game class, or the game object, just to make future expansions for dealing with the triggering code possible. We'll keep a local debug so that our debug state can be controlled, which will end up being really important, and I'll show you why in a few minutes. This is our list of keys that we care about. Currently it's blank, and then here is where we'll keep the state of the keyboard. This will show the keys that were just pressed, the keys that have been pressed, and the keys that were just released. And when I say just, I basically mean the previous frame the key wasn't pressed, and in the next update it was. So it indicates the immediate change of the state of a key. Because sometimes that's really what you're looking for, is did the user just press I, or did they just press spacebar, or did they just release enter? Most of your game related stuff will be triggered more on that. Also, for the sake of our events, we need a scoped reference to our self so we can set up our JavaScript events accordingly. So there's our constructor, keyboard manager. We'll do a quick function to essentially reset its state. If we ever want to just wipe out all the state data we have. I don't have an immediate notion to use this, but it could happen. Simple enough. I suppose the first thing we should do is build out, these will be basically our static event handlers. So for those of you who've done JavaScript development before, this will look very familiar. We're going to build a event handler for when a key comes released, and we're going to build an event handler for when a key is pressed. First thing we definitely should do here is, in case we attach the event without having built this first, we just need to pass the event on to the page to be handled appropriately, because we're not going to be able to be ready for it. But if we do have it, let's go ahead and get the string interpretation of the key code. This doesn't mean the letter or the number, it means the number. Like if you pressed one of the arrow keys, you get a number like 47. Now, the reason I'm converting it to a string is because I'm going to track it in my hash or associative array as a key, so that way I can just set it true to false as needed. So all I need is a simple hash or dictionary to keep track of the state of the keys. Excuse me. So we have our key code. First, let's see, do we care about this key code? We'll call a function called isWatched. And if we don't care, we'll pass the event on up the stack. If we do care, and the key on the last update was in a press state, then we're going to go ahead and mark it as just released. And this is somewhat important for those of you building out your experience, is that if you have debug turned on, let's go ahead and shout the key code we used. And we'll also do the from car code static function, which will return the string that key code represents. So it'll help us map. Basically, we turn debug on, we load our page, and we can actually just press keys and release keys at random, and we'll see these console events pop up, and that'll help us figure out which key codes are for which keys. So it makes I don't know, I wouldn't say it's necessarily the best way to do it, because you probably could go online and find a key code chart pretty easily, but it's nice to have. And then finally, we'll set its press state to false, because inevitably it was pressed before it got released, right? So we'll stop propagation so the event does not continue up the chain, and we'll return false, which between those two should stop the event from firing again. So we're going to essentially do almost the exact same thing, just kind of in mental reverse. We get the keyboard manager, we get the key code, we check if the key code is cared about. The only thing that's going to change here is that if the key was not pressed in the last state, we're going to set it to just pressed. We'll update this so we know we're looking at the right thing. Yep, and then we'll change this to true. We'll do this, and this is important on some, I think it's Mac, if you press the space bar, it keeps the page from scrolling, so that's kind of important. And that's it for our static handlers. So now we just need the code to put those in place. So we'll go up here, keyboard prototype, enable. And we'll also have the capability to manage a watch list straight from here, should we need it. Oh, yeah. Spell that right too. So first we'll pass the watch list over if we get one. Then we'll add our events. So we'll add to our key up, we'll add our key up static handler, and for our key down, we'll add our key down static handler, and that's it. I always forget this. And we'll basically do the same thing over here, except this is for disable. Oh, here's a good use. Here we go. In the disable, we're going to go and throw away all of our state data so that if we restart it, it doesn't have old data left in it. And instead of adding, we're going to remove event listener. Get rid of that third argument. Okay. So now we have our ability to set up our handlers. So now we just really need the ability to interrogate, because you could go to the keyboard manager object, the state, the press, just released if you wanted to, but I'm always a fan of using accessors. So we're going to go ahead and create some real quick. This shouldn't take very long, since we're just basically going to interrogate the state of a hash. So we'll do is pressed key code. Always have to convert to string to make sure that the key is appropriate. Well, that's nice. Deal with you later. So if that is, return false. I got a space here. Okay. You can pretty much duplicate most of this for was pressed, is released, was released. So the difference between is and was basically checks the the immediate that we were discussed earlier. So this would be the just pressed as opposed to just pressed. Just pressed. That's a little confusing, but I think you get what I'm saying. Is released, was released. And this one's just going to invoke its own turn not this is pressed. So it'll just invoke one of the accessors in a negative state. And then for this one, this state just released. There we go. It wasn't difficult. So now we basically just need a way to set up our watch list, because the handlers down here call is watched, so we need to build that in. So if you don't have a watch list set up, we're going to assume that you want to know about all keys. So it's for the easy prototyping stage, or you just literally don't mind having this giant array of key codes that change every time someone presses a key. But if we do care, then we need to just see if the particular key code in question is set to true or false. And now that we have a way to interrogate, we need a way to build. And then when you did our enable, we had a function called to watch. So let's just interrogate what's coming in. So basically, if all you sent in was null, then we're just going to set watch to null. So this is the watch all keys state. And then if we're continuing, then let's go ahead and blank out in case they've called this before. This will basically replace what they've set up. And now we need to get the key codes. So it could come in a few different ways. It could be an array of numbers, or they could literally pass it in as the arguments. So let's go ahead and check if there's only a single argument that comes in, and it's an array, then we just pass the array as the key codes, and if it's all the different arguments, we'll just capture it that way. Make sure I got my stuff right. Yep. And then we'll do a lazy for loop. I know there's a better way to do this, but we're doing longhand anyway, so codes idx to string is true. So I think that's everything. Let's go ahead and come back here. keyboard manager. Okay. So that should allow us to at least syntax check our library. So let's run this here. Oh, right. Gotta turn on my Apache engine. Or Python engine. Okay, it still renders. Again, we didn't wire anything up, so we shouldn't be expecting anything more than that. But now we need to actually integrate our keyboard manager into our game engine. So we'll pop back over to our game engine. We'll do a dependency injection. I do this just mostly as a way to make sure my library is loaded correctly. I essentially pass the keyboard manager class in as an argument into this closure, and it comes in as an argument to the closure. So step 1, under our init function here, I guess you probably need a place to store it. Call it keyBM. To do new keyboard manager, pass a reference to ourselves and the state of our debug, so this way we can control it all from this one setting. Well, we need a way for our keyboard manager to update, but we did not write its update function, and that's probably something we should do. What the update function does is it basically handles setting the just stuff back to not just. So at the beginning of the frame, at the beginning of the update, it basically keys are no longer just pressed because those were all handled in the update before. So that's all the keyboard manager update function does. But it is important, because if we don't, then it's always going to be triggering these events as just happening. This state just pressed. This state just pressed. False. This state just released. This state just released. KC was false. There we go. So now we can hop back in the game and tell our keyboard manager it's time to update. Well, I guess we should check if we have one in case there's a frame or two that happens before. You know, there shouldn't be. Maybe we can take that out later. But for now, we'll keep it in there. I always like to have helpers because this demo game or game class is kind of like the base to everything. So we'll go ahead and create a method called keyboard, which just returns kbm, so I don't have to remember what shorthand name I gave it. So now that should actually set up our keyboard. I'm trying to think, is there anything else we're missing? Oh, yes, there is. I guess we should at least do a quick refresh. Looks like we do have an error. Right, we need to let ourselves be known. Otherwise, the game can't find us. Okay, there we go. So again, pretty much where we left off. But now we can actually start wiring things up. And our to-do here, there we go. This keyboard enable. So So now our keyboard is actually going to start processing. My image is taking a while to load. Okay. So now, here. I mean, the zombie isn't moving, but you'll notice the log, as I press the arrow keys, is showing our key events. Here's our letter keys, number keys, spacebar, all sorts of things. Not everything can be rendered, but you see the key code in the second column, which helps us track and do the things you want to do. So arrow keys is what I'm thinking. We use our imperial arrow keys to move them around the screen at the speed that we had previously dictated. So let's get to that. Should have that in our update function. After we call our game update, we're going to check to see, well, essentially we're just going to build a movement array, which basically says, am I moving left or right, up or down? And our default is no, we're not moving either. And now we can start to interrogate. You just need to pass a key code. So for example, if we pressed up, then we go ahead and set our movement, the second value to -1, because we want the y to get smaller. Else if this KBM is pressed 40, which is down, then we want the y to get larger. Let's move it this way. Secondarily, they could be pressing up, down, up and right at the same time, or down and left at the same time. So we need to check them separately. So if they're moving left, we set their x to -1. If they're moving right, we set their x to +1. So now we have that figured out. Before we return out, we're going to have a little helper function called moveZombie. And this might hurt some of you. It's going to be a little bit of vector arithmetic, and the reason for that is if you think about how movement works, if you're moving diagonally, we need to split the speeds, because if you imagine yourself running and you turn a diagonal direction, you don't somehow get faster. But that's what would happen if all we did was add x and y to the value. So what we need to do is what's called normalization. We need to normalize the vector of -1, 1 or 0, -1 so that it's split properly if it's moving diagonal. So this won't take long. It's only a few lines. We'll first get the square root of the product of each, basically the square, the x and the y separately, and then add them together, and then get the square root of that. And if we end up with a length of 0, then we're not moving anywhere anyway, so we just continue on. But if we are moving, here is where we will add the vector movement of the x property adjusted for moving diagonally, and we multiply that by how much we want to move in that frame, which we figured out earlier. And we'll do the same thing to the y side. And that's it. And if we refresh, give it a second for my image to load. Oh, 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 oh my gosh. And see, he moves at the same speed even if he's moving diagonally. I think I had this set up to 120 pixels per second, so it takes him about 5 seconds to cross the screen lengthwise, 6 seconds, that's about right. You can go off screen because we don't have any constraints. So now we have our very first interactive control scheme. And we did it by building it into our engine. And the great thing about that is now, if we obviously keep a copy of these engine files separate. If you want to work on another project, you don't have to retype everything. You don't have to rebuild the engine from scratch. You just have to basically do this part, and then one line here, and then one line here. That's it. All the rest is all custom for your individual product. So this was kind of a lengthy episode, and ultimately ended up being, stuff happened. We can actually have the idea of an experience now, but I'll put in a simple mouse manager into the code base for our next one. Essentially, it'll just allow you to click and jump right to there, so you'll get to interrogate the mouse position and the state of the buttons. So it'll be the same basic idea, just to be for the mouse instead of the keyboard. But I think that's enough shop talk for one video. Hopefully this hasn't been putting too many of you to sleep, but at least you can kind of see where we're going to go with this. And thankfully, because we started working on this engine now, future stuff we can get set up and propped up much quicker, so we can get to doing things that are a bit more interesting. So for our next video, I had thought about doing something for managing your game data. So this would be things that affect the mechanics of how things work, like the speeds of things, the stats of things. Typically, new game designers will just throw them in their code and not think about it. But really, it's very, very important that you externalize those, because you're going to be making a lot of changes to them. And it's really hard to find that one mention deep in the code you forgot about to figure out why something isn't working. So we're going to show a really simple, and again, it's a simple engine addition that we can use so we can keep track of all our game data using a very simple and methodical approach. So hopefully some people found this video enjoyable. As usual, let me know if you hated it or like it or want to hear more about something, and I'll see what I can do. So until next time, have a good afternoon from the EvilTreeHouse. See you later, folks.